Hello grade 9 students. Welcome to another virtual class. I am Miss Madhu Vadke. We are studying chapter 4 linear equations in two variables. In today's video lesson we will cover the last section of this chapter, which is about equations of lines parallel to the x-axis and y-axis. And then we will solve the questions of exercise 4.4. Consider these points 2, 0, minus 3, 0, 4, 0. Can you guess where these points lie on the Cartesian plane? If your answer is x-axis, then you are right. These points lie on x-axis. And what is the reason? Notice that the y-coordinate of all of these points is 0. So we can say that these points lie on the x-axis as y equal to 0. Observe that y equal to 0 is an equation which will be satisfied by all these points. We can write y equal to 0 as an equation in two variables as 0 times x plus y is equal to 0. Now if I substitute any of these points in this equation, we will always get y equal to 0. This implies that y equal to 0 is the equation of x-axis. Likewise, let's consider points 0, 1, 0, minus 4, 0, 5. Where do all these points lie? If your answer is y-axis, then you are right. These points will lie on y-axis. Why? Because these points have their x-coordinate 0. Now again we get an equation x equal to 0, and we can write the same equation as equation in two variables as x plus 0 into y equal to 0. So notice that on substituting any of these points in this equation, I will always get x equal to 0. So these points that lie on the y-axis satisfy this equation x equal to 0. This means that the equation of y-axis is x equal to 0. Now what type of equations will represent lines that will be parallel to x-axis? Let's understand this by answering the first question of exercise 4.4. Give the geometric representation of y equal to 3 as an equation in one variable and in two variables. The given equation is y equal to 3, which is already an equation in one variable. The solution of this equation is unique, that is equal to 3. And this solution can be represented on the number line. See that you mark these numbers at equal distance using your scale. So y equal to 3 is a point on the number line over here. This is how we can represent this equation in one variable on the number line. But the same equation can be written as an equation in two variables as 0 into x plus y minus 3 equal to 0. I have carried 3 to the left side, and since there is no x term, I am writing the x term as 0 times x. Now since this is an equation in two variables, it will have infinite solutions. Let us find these solutions. Let's take the values of x as 0, 1, 2, 3. On substituting these values of x, we will find that we always get y equal to 3 as the corresponding value. You can verify these points after substituting. So the solution points are 0, 3, 1, 3, 2, 3, 3, 3, and so on. Let's represent these points on the graph. So 0, 3 lies over here, 1, 3 is here, 2, 3 is here, and 3, 3 is here. On joining these points, you will get a straight line that is parallel to the x-axis. So y equal to 3 is an equation of a line that is parallel to the x-axis and at a distance of three units from the x-axis. So every point on this line will be a solution of this equation y equal to 3. Can you write a general form for this point, which is a solution of this equation? Notice from the table of solution that the y coordinate is always a constant 3, no matter what value of x you choose. So a solution point of this equation can have a general form x, 3. You can substitute different values of x, but the value of y will remain as 3. So a point in this format x, 3 will lie on this line. And the distance of this line from the x-axis is equal to its y coordinate, that is 3 units. We can generalize this understanding and say that an equation of the type y equal to b will be a line parallel to the x-axis at a distance of b units from the x-axis, and a point that lies on this line will be of the type x, b. Next, what kind of equations will represent lines that will be parallel to the y-axis? Let's understand this by answering the second question of exercise 4.4. Give the geometric representations of 2x plus 9 equal to 0 as an equation in one variable and in two variables. In one variable, 2x plus 9 equal to 0 can be solved to get the value of x as minus 9 upon 2, which is equal to minus 4.5. So this is a unique solution of this linear equation in one variable, which can be represented on the number line. X is minus 4.5. So from the origin you will move towards the negative side of the number line by 4.5 units. So your point will be here. So this point over here represents x equal to minus 4.5. This is the geometric representation of this equation in one variable, which will be on the number line. Now we will represent this equation as an equation in two variables. Since the y term is 0, we can write this equation as 2 times x plus 0 into y plus 9 equal to 0. Since this equation is a linear equation in two variables, it will have infinite solutions. Let's find few solutions so that we can plot on the graph and represent this equation. In this case, we are going to choose values of y and then find corresponding values of x. So let the values of y be 0, 1, 2, 3. After substituting these values, you will find that the corresponding value of x for all these cases will be same, that is equal to minus 4.5. You can verify this by substituting in your rough column and calculating. So the corresponding points are minus 4.5, 0, minus 4.5, 1, minus 4.5, 2, minus 4.5, 3. Let's represent these points on the graph. Draw the x-axis and y-axis accordingly so that these points that we have found can be shown. Minus 4.5, 0 will be a point on the x-axis over here. Minus 4.5, 1 will be a point over here. Minus 4.5, 2 will be a point over here, and minus 4.5, 3 will be over here. On joining these points with the ruler, you will get a straight line that is parallel to the y-axis. Label this line with the corresponding equation. Notice that the distance of this line from the y-axis is minus 4.5 units. Also, this equation has its y term 0 and is parallel to the y-axis. And all points on this line will satisfy this equation. Can you write a general form for these points that will lie on this line? Looking at the table of solution, you can see that x is constant for different values of y. So a general form for the solution point will be of the type minus 4.5, y. So all points in this format will lie on this line. You can change the values of y, but the corresponding values of x will always be minus 4.5. So we can generalize this understanding and conclude that an equation of the type x equal to c will represent a line parallel to the y-axis at a distance of c units from it, and a point that will lie on this line will have coordinates c, y. Let's write down a quick summary of what we have learned today. Equation of x-axis is y equal to 0. Equation of y-axis will be given by x equal to 0. An equation that does not have an x term will represent a line that will be parallel to the x-axis. An equation that does not have a y term will represent a line parallel to the y-axis. So we can conclude that the general form of an equation that represents a line parallel to the x-axis is y equal to b, where b is the distance of this line from the x-axis, and a point on this line is given in the form x, b. Likewise, an equation that represents a line parallel to y-axis is given by x equal to c, where c is the distance of this line from y-axis, and a point lying on it will be of the type c, y. And we also studied the geometric interpretation of linear equation. When we express this equation in one variable, it represents a point on the number line. And when we express this equation in two variables, it represents a line on the Cartesian plane. With this, we come to the end of this video lesson. Your assignment for today is this example question from NCERT textbook. Solve this equation and reduce it to the standard form, and then represent the solutions on the number line and on the Cartesian plane. This means that in the first case you will represent this equation as an equation in one variable, and in the second case you will represent this equation as an equation in two variables. See you in the next class. Until then, goodbye.